Hi. Now it is section 30.8, derivatives of inverse functions and logarithms. We'll begin with derivatives of inverse functions. If f is differentiable and has inverse, then we can say this: start from x and f is applied, and then f inverse is applied, then it'll go back to the original point. Here, pictorially, domain of f and codomain of f, and x is here. By applying f, it is moving at here f of x, and along with inverse, f inverse, it'll go back to the original position. Now, if we apply chain rule to that equation, then x derivative of the whole thing is the same as f inverse, the derivative of f inverse with respect to fx, and times derivative of f with respect to x, and right hand side is 1, and we divide equation by f prime x to get that 1. Here, roughly speaking, f inverse prime is reciprocal of the f prime, but you have to be careful here. Now that is evaluated at f of x, that is evaluated at x. Let's see here. If y equal fx is given in this way, then y equal f inverse x is given that way. So it is a reflection with respect to y equal x. Now, if this point is x, the x coordinate is x, then the reflected point, that one, is now f of x. So that here, the slope at this point is reciprocal of slope at this point. So geometrically, we can interpret the formula. Similarly, starting from here, now f inverse of x equal x, we apply the chain rule, then that will be here now f prime with respect to f inverse of x times f inverse prime with respect to x must be 1. Now, we divide the equation by that term, we can reach at this formula. We'll use this formula quite frequently, and when we are trying to get the derivative of inverse function. And also I'll try to explain what the equation exactly means, solving examples. Yeah. Okay. Now, f of x is given in this way with x larger than 0, then it is 1-to-1 and it has inverse. Now, we want to find f inverse, derivative of f inverse at x equals 6. And here, we'll try to solve the problem by using two methods. One is along with the explicit construction of f inverse, and another one is using this formula. Okay? Okay, here, we can construct f inverse explicitly in this way. We already know that fx is given, then we start with y equal fx, that is x cubed minus 2, and we solve it for x, so it's y plus 2 equal x cubed. From this one, now x is the same as, and 1/3 power, so that third root of y plus 2. And here we exchange x and y, then here y equal third root of x plus 2, which is same as f inverse of x, right? And here we got f inverse of x. Of course, that can be written again x plus 2 1/3 power. So if we are making the differentiation, apply the differentiation operator prime here, then now the power will go out, and then here x plus 2 and the power minus 1, which is a minus 2 over 3, and the derivative of this variable, which is 1. Okay, so we reach at here, that is now 1 over 3 times here x plus 2 and 2 over 3 power. So f inverse and prime, now the point is 6, so that we put over the 6. Then that is same as 1 over 3 and times 8 of 2 over 3, which is now 4, so that the value is 1 over 12. We got this value. Okay. Now we'll try to use the formula. And here, now, okay, f inverse, derivative of f inverse at 6, that is exactly over there. So we have to find, anyway, for given x, we have to find f inverse of x, so that if we are following the formula, then, okay, this quantity must be same as 1 over f prime at here f inverse of now 6. So we have to find the corresponding point here, and that is same as, okay, now if we start with x equal now f inverse of 6, then that is same as 6 equal f of x. What is f of x? That is now x cubed minus 2. So that if we try to solve the problem, then that is x cubed equal 8, so that x equal 2. X itself is now f inverse of now 6, so that we found 2. So that means that here, in the beginning, it will be a little bit confusing. But now, in the next problem, I'll explain one more time different viewpoint of finding point, the corresponding point. Okay, so here, that is true. So the given term must be same as 1 over f prime at 2. Okay, here we found the f inverse of 6, that is 2. Okay, so that will determine the final answer. Now we have to find f prime, that is now here from f of x, that is 30 x squared, minus 2 will disappear. So from here now, f prime at 2 equal 30 times 2 squared, which is 12. So we got here 1 over 12. So we got the same result as with the explicit construction of f inverse. Okay. Now here, and f is given in this way, and we want to find a derivative of f inverse at minus 1. Okay, let's think in this way. Here, pictorially, now if it is domain of f is given here, and of course here now x is larger than or equal to 2, and that is now codomain, and then f is given over there. Now, F inverse is defined the opposite direction, so that this is domain, and that is now range of F inverse. Here, the F inverse is defined here, and we have to find the slope at here -1. One of these point in the domain of F inverse is -1. Now, we have to use the formula here that is related with now F prime, but F itself is defined the other side, so that you have to measure F prime in the other side, but the point is basically here the corresponding point of -1 over there. So you have to find first the corresponding point of -1 in that here now. You have to find this one. That's the question. Let's say that is x. Then that means that here x equal F inverse. Okay, F inverse is that direction, -1. That means that Fx equal same as -1. Right? That's the reason here we try to solve that equation. F inverse is defined in this side. F is defined on that side. So that, and for that quantity is reciprocal of F prime, but F prime cannot be defined over there. It's defined in this side. So you have to find a point, the corresponding point in that side, left side of the domain over there. So that's the reason geometrically, and we are solving that one, so that this is a geometric explanation why we are working on this way. Okay, it's quite simple. Okay, now we'll solve that one to find the x. Now fx, that is x cubed minus 3x squared minus 1, which is -1. So -1 will be cancelled, and now x squared and x minus 3 equal 0. Now x must be larger than equal to 2, so this cannot be 0, and only choice is x equal to 3. Okay, so this point is now 3. So here, the given quantity, the required quantity is same as 1 over f prime at the corresponding point, which is 3. Right? So now to finalize the answer, we have to find f prime. Now f prime, that is 3x squared from here, and minus 6x, right? Yeah, 6x and 3x squared. Okay, so f prime at 3, which is now 27 minus 18, so that will be 9. Okay, so the final answer is 1 over 9. Okay, simple. Now it's quite easy to see, right? We'll do one more here. And fx is given x squared minus 4x minus 5, and x is larger than 2. That's the domain of f. In this case, it's increasing function and has inverse, and we have to find derivative of f inverse at x equals 0. Now here, that is exactly now at x equals 0 means that if you are considering the domain of f and codomain of a range of f, then f is that direction. Now we have to find the derivative of f inverse at here the point 0. So first you have to find the corresponding point here. So that is now x. So that is exactly here by solving fx. That's x squared minus 4x minus 5 equal 0. That 0 here now. By solving this equation, we can find that point x. Okay. Now, x separation and 4, okay, not 4, is basically 1 and 5 separation. There's a minus and plus, which means that x equal minus 1 and 5. But x must be larger than 2, which means that we have only the point x here. So x is 5. That point is now 5. So here we can say that d over dx f inverse at here the point 0 is same as 1 over f prime at 5. So we have to get f prime, that is 2x minus 4, and f prime at 5, which is now 10 minus 4, which is 6. Right? 2x minus 4. Okay. So that the answer is 1 over 6. That is the final answer. Now it is quite simple, right? The derivatives of inverse functions is not so much complicated. You have to consider the thing quite reasonably so that f is defined from this left-hand side, and f prime also should be evaluated from this side. F inverse is defined on that side, so the derivative of f inverse must be also evaluated that one. But the formula is given in this way. Here, the f inverse prime is 1 over f prime, but the x for given point, you have to find the corresponding point to the left-hand side. Okay, that's a geometric interpretation. Okay, this is the end of the first part, and we'll continue in the second part. Thank you.